All right, Algebra 2, Section 4.7. Now we're getting to our third way of learning to solve quadratic equations, and this one is called the quadratic formula. So just to recap, the first method we learned back in Section 4.5 was factoring. Factoring was pretty nice and pretty easy and pretty quick. The problem was it doesn't always work. The second way we learned in 4.6 was completing the square, which works really well under certain circumstances, but it works pretty darn badly under other circumstances. So the quadratic formula is kind of going to be your third option here for solving quadratic equations. And unlike those other two, this one is pretty universally applicable. You can solve any quadratic equation. In fact, I should throw that word up here, solving any quadratic equation. Let me get rid of that then, using the quadratic formula. This works all the time. Now, what we have right here, everybody, you might recall, is a quadratic equation written in standard form. If you went all the way back to your notes from the beginning of this chapter, the very first section, you would find this written out. And I just put it here to remind you guys that A is defined as the coefficient of the x squared term. B is the coefficient of what we call the linear term, just the x, and C doesn't have an x on it at all, so C is our constant. So that's just a little reminder about what the A and the B and the C represent. So here we go, guys. This is what you want to make sure that you have written down exactly right in your notes with a big box around it, and we're going to have to study this and recite it and have it memorized here. Here we go. X is equal to, go ahead now at this point and draw this big fraction bar going across. And in your numerator, you have the opposite of b. Let's not say negative b. The opposite of b plus or minus the square root of b squared minus 4ac, all of which gets divided by 2a. And again, the a and the b and the c that we're referencing in this formula all come back to standard form of a quadratic equation there, the a and the b and the c that we see right there. Okay, this formula here, guys, is one of the cooler things that we're going to learn here. Really, it's an Algebra 1 topic, but here we are learning it again in Algebra 2. And I tell you what, nobody cares, let's be honest. So at the very end of the notes, I'm going to come back and talk about where the quadratic formula comes from, but I think I'll spare you guys that right now. Let's see how we can use it. Now, the nice thing about the quadratic formula is, even though it's messy, you can just dive in and start using it. Once you have the formula down, there's really nothing else to say. So here we go. This quadratic equation here, x squared plus 5x minus 66, is one we can solve using the quadratic formula. So let's get some practice at writing this out, guys. X is equal to, big fraction bar now, it is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The more you write it and the more you make yourself say it, the faster you're going to learn it. So now let's start plugging in our values here for a, b, and c. So it's never a bad idea, guys, to just off to the side right here, write out what those three values are. Now my hope is you'll be able to do this without writing it out, but hey, it's our first one. A is the coefficient of x squared. And you might be tempted to say there is no coefficient. No, that just means that our a value is 1. B is the coefficient of x, which is going to be 5. And c is the constant at the end, which is negative 66. I should point out, all of this is possible here because this equation is already set equal to 0. And pretty soon we're going to see some examples where the right side of your equation is not 0. Well, guess what? The first thing we're going to need to do is move these two terms over to the left side so that we do end up with a big fat 0 on the right. So you can't really dive into this until you get your right side equaling 0, but we're already good there. All right, let's start filling in our numerator. The first thing we need is the opposite of b. If b is 5, then the opposite of b is going to be negative 5. Plus or minus the square root of, and here we go. Now at this point, I would really recommend that you guys do just a little bit of mental math right here. B squared is something I think you can normally do in your head. In this example, b is 5. I would go ahead and square that right now, and make a 25. Later on in this video, I'll tell you why I think that's a good idea to do there. Minus 4, and then guys, I can't recommend this strongly enough, use parentheses here for your A and your C. Our A value is 1, and our B value is a negative 66. Okay, so that takes care of the numerator, and the denominator is 2 times an A value, we said, of 1. Okay. So that takes care of all the substitution there. Now it is a matter of plugging everything in right here and getting all this to work out. We got to work underneath the radical sign first, guys. So this is going to be negative 5 plus or minus the square root of, and now I'm going to give you guys good news. At this point, I would go ahead and use my calculator if I were you guys to type in everything under the radical, but I wouldn't do the radical itself just yet. You'll see why here pretty soon. But it's really important, everybody, that you put all of this into the calculator in one step and only hit enter or equals once at the very end of that process. So I'm going to open up Desmos right here, and here we go. We had a 25 minus a 4, and then in parentheses our A value was a 1, and then our C value then was a negative 66. There you go. Let's close that parenthesis and hit enter, and we got 289. But please notice, I only hit enter once at the end of that whole process right there. So this number, guys, is called the radicand, the number that you get underneath your square root sign, although we're going to learn a different name for it pretty soon here in this section. And in the denominator, 2 times 1 is going to get us just plain 2. Now at this point, your quadratic formula can look very, very different from problem to problem right here. We're going to see what kind of problem we're dealing with right here. The first thing to notice is that radicand right there we came up with of 289, and we're now trying to take the square root of that number. Whether or not that number we came up with is a perfect square has a big impact on how difficult this problem can be to solve. Now that might be a number you guys don't quite recognize, so let's go to the calculator and type in the square root of 289, and sure enough, that one works out to be a whole number, 17, which means 289 was a perfect square, even if you didn't know that. All right, so x is equal to, we're now at a negative 5 plus or minus, and the square root of 289 we learned is 17 all over 2. Now, with what we've been doing here so far in Chapter 4, we have not been at a point quite like this yet, so let's talk about how to handle that. First thing we're going to do now, guys, is deal with our numerator, and remember, that plus or minus is actually 2 different cases. We have to handle them one at a time. So we're going to get one solution right here, or another one right here. Positive case first, everybody. Negative 5 plus 17 is going to get us 12. And that 12 is then going to get divided by the 2 on the bottom. And I'll clean that up on my next step. Now the second case, we look at the negative here. Negative 5 minus 17 is negative 22. That all gets divided by 2 as well. So here's our 2 solutions now, guys. X equals 12 divided by 2 is 6. That's one of them. Or the second solution, negative 22 divided by 2 is negative 11. And those are my 2 solutions to this quadratic equation. Positive 6 or negative 11. Now, how could we test these to find out if we're right? Well, like every equation you guys have ever solved, you could always put those 2 values back into the original quadratic function and make sure that it works out. I don't know how difficult that would be to do by hand. Let's try it real quick. If I plugged a 6 in, 6 squared is 36, plus 5 times 6, which is 30, minus 66. I could do that in my head. 36 plus 30 is 66. Minus 66 equals 0. So that one checks out. Going to be a little bit harder now to plug in a negative 11. Let's see if we can do it, guys. Negative 11 squared is a positive 121. And then plus 5 times a negative 11 would be minus 55. And then a minus 66 at the end. That should equal 0. But let's try it, everybody. Here we go. Okay, a 121 minus 55, and then a minus 66, and that gets, oops, I didn't want that button, I wanted that button. Yeah, that does equal 0. So both of these answers get us solutions that actually work out. Now, of course, I'd be remiss if I didn't mention this. Let me switch to another color here. How about this? Let's go with this lovely shade of orange right here, guys. This quadratic equation right over here, if you took a look at the numbers at all, this one, I'm pretty sure, actually is one that we could have factored using the method that we talked about back in section 4.5. Let me just take a look here. If I break that up into two binomials, the x squared would be x times x. The signs would be different, 1 plus and 1 minus, and I would need two numbers now that multiply to negative 66 and combine to 5. Since the signs are different, that means they have to subtract to 5. Positive 11 and negative 6 will work there. Here we get a negative 6x and a plus 11x. That's the plus 5x that we needed in the middle. So what solution do we get right here? You set x plus 11 equal to 0 and get x equals negative 11. Or right here, you set x minus 6 equal to 0 and get x equals positive 6. So, if I zoom out again so you can see everything here, what you will notice, I hope, is that we came up with the same two solutions by factoring that we got by doing the quadratic formula. So what point am I trying to make here? Given the choice, if factoring happens to work, you're much better off doing the problem this way rather than messing with all of this work here for the quadratic formula. So factoring is definitely the first thing that you ought to look for. But the kicker here is, everybody, factoring doesn't always work. And you are able to get certain types of solutions with the quadratic formula you're not able to come up with when factoring. But if you could factor, by all means, go ahead and do that first. But let's take a look at our next example here, everybody. And I think, if I'm remembering correctly, this example is going to prove my point here a little bit. Okay, we have x squared minus 18x plus 9. And if I were, to try to factor this, don't write this down, everybody, I would have an x and an x equals 0. Signs looks like they're the same and they're both negative, so minus, minus. And now I would need two numbers that would have to multiply to 9 and add up to 18. 3 and 3? No, that adds up to 6, so that wouldn't work. The only other choice for 9 would be 1 and 9. Those add up to 10. So right here I ran into a problem trying to do factoring. This one doesn't factor, and so I need everybody to understand then that a lot of quadratic equations that we have, factoring simply does not work. But the quadratic formula will. So here we go. X is equal to, let's write out the formula again, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. I'll say it again, guys. The more you write it and the more you say it out loud, the better you guys are going to be at actually memorizing this formula here. Okay? All right, so with that in mind, guys, here we go. Let's fill in what we know. All right, we've got x is equal to, and let's go get them. Now, b here, you will notice, is negative 18, so the opposite of b is now going to be a positive 18. That's why I like you guys to say the opposite of b and not necessarily negative, because half the time, the opposite of b ends up being positive. Plus or minus the square root of, and again, this I would do by hand right now. Now, b is negative 18, and when you go to your calculator and you square negative 18, you have got to remember to put that negative 18 in parentheses before you square it. If you don't, you're going to end up with a negative result. But as soon as I ask you guys, you all know this, any number, positive or negative, squared, which means times itself, is going to end up being a positive number. So if I were you guys, I wouldn't even put the negative number in my calculator. I would just type in 18 and then square that, and here you go. 324 is the value of 18 squared. So 324 minus 4 times an a value of 1 and a c value of 9. Got it. All over 2 times, again, an a value of 1. All right, let's see what that does for us. And I tell you what, guys, I might try to work across here to save a little bit of space. This is going to be 18 plus or minus the square root of, and just like in the last problem, I would do all of this radicand in your calculator in one big step. So let's type in, here we go, 324 minus, we have 4, and then in parentheses we have 1, and then a C value, shoot, I forgot, I think it was 9. Is that right? Yeah, that C value there was 9. Cool, close the parenthesis and hit enter, we get 288. All right. So a 288 is going to go right there, all over, and a 2 on the bottom. Now, kids, the party's over. In the last problem that we did, I made it so that the number we ended up with in the radical was a perfect square, and the square root of 289 just became 17. Here in this problem, your radicand is 288, which is not a perfect square. If you were to type that into your calculator and ask it what the square root of 288 is, you're going to get a big messy decimal. That means our answer here is what we call irrational. All right, so it's not as easy as the last problem. So what are we going to do with that? Well, this is new here, guys, and we haven't dealt with this too much before. We're going to have to simplify that radical. And what we're going to do then, I'm going to try to cram this all in this one step right here, guys. We're going to have to get rid of the 288 and look for a perfect square that divides evenly into that number. Now, we've already talked about some strategies for doing this. Here's what I would recommend. 288 is clearly not a perfect square. The next thing you should do is think about cutting that number in half. And half of 288, write it over here if you need to, divided by 2 is 144. And that number, as luck would have it, is a perfect square. So I'm going to cross out the 288, and make it 144 times 2. Then, this is kind of my shortcut method, I circle the perfect square, and on the next step, we're going to bring the square root of that number out in front of the radical right here. So this numerator is now going to become 18 plus or minus, and the square root of that 144 is 12. That gets multiplied by this 2 under the radical here that just kind of got stuck there. So the square root of 288 simplifies now into 12 times the square root of 2 all over 2. Now, where do we go from here? In some cases, you guys, you're done with a problem like this. But in this one, you can go a little bit further. There are 3 numbers you need to be looking at. This number right here out in front of the plus or minus, this number right here in front of the radical, and this number down here in the denominator. If those 3 numbers have a common factor that you can divide out from all 3, you need to do that. So this 18 gets divided by this 2 to make a 9. And then plus or minus, this 12 gets divided by 2 to make 6. Now, the 2 under the radical is protected by that radical. It does not get divided, and so that 2 stays exactly the way that it is. And technically, don't bother writing this down, the denominator is still there. You take that 2 and divide it by 2 as well, and you get a 1 down in your denominator. But of course, there's no point in ever writing a denominator of 1. So in a case like this, that is your final answer. Everybody be very careful. This does not equal, for example, 15 root 2. You can't add the 9 and the 6 here together because this 6 has a factor of root 2. That's like taking 9 plus 6x and trying to tell me that it's 15x. That's an Algebra 1 mistake, and it doesn't work. This doesn't work here either. So, one of the things you guys need to practice here, and the reason we check our answers to homework problems, is to get used to seeing what is an acceptable format for some of these ugly, hard answers that we come up with. And 9 plus or minus 6 root 2 is one of those acceptable formats. It's not going to get any better than that. So, unfortunately, because we ended up with an irrational solution, you really can't take this answer and plug it back into the original equation and make sure that it works. I'm going to ask you guys to trust me on that one right there. So that's the answer to this one, 9 plus or minus 6 root 2. And remember, that's actually 2 different answers. All right, let's take a look at a third example. Now this one's a little bit harder because our equation was not already set equal to 0. So step number 1, get it equal to 0. We're going to make sure that the x squared terms are positive. Although that's not essential, it makes life a little bit easier. I got a 4x squared on the left, a negative 1x squared on the right. We're moving the little one to the big one. So we're going to add x squared on the right and balance that by adding x squared on the left. That means I also need to get rid of that 9. We're going to subtract 9 from the right and from the left. So those terms cancel, and let's see what we have. 4x squared plus 1x squared is 5x squared. We're not combining anything with the minus 2x, and a plus 7 minus 9 is going to give us a minus 2, all of which is equal to 0. Okay, so let's dive in here, guys. X equals, and I tell you what, this is our third time doing it. I'm going to leave out writing the actual formula, and let's dive in. Hopefully by now we kind of know it. The opposite of b is how we begin. b is negative 2. The opposite of that will be positive 2. Plus or minus the square root of, and here we go, b squared. So that number right there is negative 2 times itself. Negative 2 times negative 2 is 4. And let me stop you guys right there. Just a quick reminder, this number that you come up with right here, b squared, will never be negative. If b is positive, it's a positive times a positive, which is positive. But if b is negative, like it was in this case, it's a negative times a negative, which is going to be positive as well. So this number can never be negative. If you ever find yourself putting a negative number there, you messed up. You probably did it in your calculator without putting a parenthesis around the negative number. So you'd have to type it in like this, negative 2 squared. Okay, so there's b squared minus 4 times an a value here of 5, first time we've seen that, and a c value at the end of negative 2, all over 2a, where a is that 5 value again. And while we're at it, let me again try to save some space right here. We're going to have a 2 plus or minus the square root of, and what we're going to do here, guys, is we are going to take all of this radicand, and I would say let's put that all into the calculator at once. Okay, 4, 4, 5, negative 2. Let's see if I can remember that. All right, so it was going to be 4 minus 4, and then in parentheses we had a 5 times a negative 2. There we go. And it looks like all that is going to equal 44. Okay, so that's a 2 plus or minus the square root of 44. And in the denominator, the 2 times 5 is going to get us a 10. Okay, now, not really decision time, but we better figure out what we're dealing with. Ideally, this number would have been a perfect square. It is not. So, is there any perfect square that divides evenly into 44? So start by cutting that number in half, which would get you 22, and look for perfect squares then less than 22. 16 doesn't work. 9 doesn't work. 4 does. So that 44 is going to become 4 times 11, and 4 is the perfect square that I'm going to pull out in front. I should say the square root of 4 I'm going to pull out in front. So x equals, here we go now, guys, we've got a 2 plus or minus, the square root of that 4 is a 2, and the 11 gets stuck under the radical. So 2 root 11 all over 10. And just like we did on the last problem, we need to look here, here, and here for a common factor that can be divided out. And again here, we end up with a 2. So let's divide that out. This 2 divided by 2 is 1. Plus or minus, this 2 divided by 2 is 1 also. We don't need to write that 1 there, though, because it just gets multiplied by the square root of 11, and there's no point in putting a 1 out in front of that. And the 10 in the bottom gets divided by 2 to leave us with a 5. That is not going to simplify any more than that. That's our answer here, guys. The two solutions that we came up with for example C, 1 plus or minus the square root of 11 over 5. Okay, so hopefully you guys are starting to get a sense for how problems like this work. I had one more that I wanted to do with you. I think we'll go ahead and do this, and then I think at that point I'm going to cut this video off, and then we'll start a new one for these last few slides. So one more here, guys. Example D. I would really advise you, if you think you know what you're doing here, pause the video after you've written this problem down, try it on your own, then come right back to it and see if you got the right answer. All right, let's do it together though, guys. Here you go. 9x squared on the left, 10x squared on the right. We move the smaller one to the bigger one. Again, although this is not necessary, that's how most people like to handle it. That means I'm also going to move this negative 4x by adding it on both sides. And you'll notice this doesn't have a like term. Okay. So where are we? Those 9x squareds cancel. Those 4x's cancel. My left side is now 0. And it equals, well, 10x squared minus 9x squared is 1x squared. This 4x doesn't combine with anything, so it's just plus 4x and then a plus 4 at the end of all that. Okay, gotcha. And as I'm looking at this, I think this one works out pretty nicely. All right, here we go. X is equal to, let's start with a big fraction bar and let's go get it. The opposite of B. B is 4, so its opposite is going to be negative 4. Plus or minus the square root of, and here we go. B squared, 4 times 4, 16. Remember, that number is never negative. Minus 4 times an A value of 1 times a C value of 4. Now I remember why I gave you this problem. All over 2 times your A value, which again was 1. Okay, what does that do for us? We're going to go ahead and do all of this in one step here, and you guys would probably want to do it in your calculator. We're going to end up then with x equaling negative 4 plus or minus the square root of, and this is interesting, 4 times 1 times 4 is 16. 16 minus 16, we end up taking the square root of 0, and we get that all over 2. Now 0, even though it seems a little bit weird, you guys, is a perfect square. What number times itself equals 0? 0. So you end up now with negative 4 plus or minus 0 all over 2. Well, this gets pretty easy now. X equals, here we go, negative 4 plus 0 is negative 4 over 2, and then we'll just simplify that to get x equals negative 2. The second case would have come from negative 4 minus 0, but negative 4 minus 0 is still negative 4 and divided by 2, and we still end up with x equals negative 2. This is the one and only solution to this quadratic equation. So the reason I did this example with you guys, I wanted to point out most quadratic equations have two solutions. Let's review all this real quick. This problem had, 2, 6, and negative 11. The second example had 2. It was 9 plus 6 root 2 and 9 minus 6 root 2. That's two different answers. The third example, 1 plus root 11 over 5 and then 1 minus root 11 over 5. But in certain cases, like this one right here, you end up with only one solution. Now, the reason for that, guys, deals with this concept right here. Since we started solving equations by square roots at the beginning of 4-6, we've been talking about the idea that almost every number has two square roots, a positive and a negative. So if we were doing a problem and we took the square root of 25, we would have to put a plus or minus in front of our 5 for our answer. But if the radicand you're dealing with is 0 and you try that trick there, the square root of 0 equals plus and minus 0, well, there is no such thing as negative 0. There's just one number right there, and 0 has no sign. It's neither positive nor negative. So this is the one case here, guys. If your radicand is 0, that's when you're only going to end up, in fact, let me write this out, with only one solution, because 0 has only one square root. Any other number, like if you ended up with a 25, you would have ended up with two solutions. So when I pick up this next video, we'll talk about why that is. So that's a wrap for this one. That last video will just clarify some ideas here that might make these problems easier for you moving forward.